Welcome to another video on a Sisney channel, guys. Welcome. In this video, I will introduce to you number theory and computation. Before we go any further in this video, remember to click the subscribe button and the notification bell and like this video. Well, let's go. So, every day you go to math class and this thought of how does all of this matters keeps popping up all the time. Let's see a show of hands for those who are guilty of this. Well, that thought of number theory and computation is why you are now watching this video, wanting to know what this is and if it makes sense. Okay, so let's look at buildings. Buildings need a strong foundation to start it off, so that it does not go tumbling down. Look at the Leaning Tower of Pisa. Would you say it has a strong foundation? Well, I'll leave you to think about that. Well, it's the same thing with number theory. Number theory is the foundation of math. Not knowing it may just be one of the reasons why you may be failing math or don't do very well at it. So, what is number theory? Number theory is a pure math. It is so pure, you can see right through it. It is a branch of math that is devoted to the study of different types of numbers. It shows the relationship and pattern among the different types of number. Isn't that fascinating for you? So, how does it all make sense? Well, number theory is all around us. It's been used in our technology, weather, time, day, year. Everything that you can think of, number theory is there. It's even in how you spend your money. So basically, without this foundation, we would all just collapse. So let's look at the different types of numbers in the number theory. In this video, I will share with you 10 types of numbers. The first type of numbers are natural numbers, which are also called counting numbers. For example, 1, 2, 3, and infinity. The second number is whole numbers. These are natural numbers including 0, 1, 2, 3, and infinity. So, whole numbers, we then look at integers, which are whole numbers including negative numbers. Therefore, they are positive and negative numbers. For example, 0, 1, 2, 3, and infinity for positive numbers, and for negative number is negative 1, negative 2, and negative 3, and infinity. Moving on to rational numbers. These numbers are integers expressed as fractions. For example, a negative half, a 2/3, and many more. Then we get to the real numbers. Real numbers are all whole numbers or decimal numbers. For example, 4, 5.5, 3.5, and so on. So if there are rational numbers, then there must be irrational numbers. Irrational numbers are numbers that cannot be expressed as a fraction. For example, pi. Now guys, I'm not talking about the pie that you eat. I'm talking about pi. Pi as in 3.142. This cannot be represented as a fraction because 3.142 number continues on and on into infinity. Then we look at even numbers. These are numbers that are divisible by 2. For example, 2, 4, 6, and so on. Odd numbers. These are the opposite of even numbers, which simply means that they are not divisible by 2. So when they are divided by 2, you would get a remainder. So for example, 1, 3, 5, 7, and so on. Prime. No, not Amazon Prime. So, prime numbers. Prime numbers are numbers that a prime number is a number that is divisible by 1 and itself. In other words, it has only 2 factors, right? For example, 2, 3, 5, and so on. Last but not least, composite numbers. These are numbers that are multiples of at least two numbers other than 1 and itself. For example, 4, 6, 8, and so on. Easy peasy, right guys? Let's move to math computation, to solving problems using Bondas or PEMDAS. So many times we get these equations or math problems, but we never know which operation to do first. Well, that's where we use Bondas or PEMDAS. Bondas is where B means bracket, O means order in terms of indices or exponent, M is for multiplication, D division, A addition, or S subtraction. While for PEMDAS, the only difference is P, which is parentheses. Let's look at some examples using Bondas. First, which is 2 times 4, which gives you 8. Then, that would equal to 8 plus 5 minus 1. You then add 8 plus 5, which will give you 13, minus 1, which will overall give you 12. In our next example, you want to do multiplication first. 2 times 2, which will give you 4. So therefore, it now equals 4 divided by 4 plus 3 minus 1. We then divide 4 by 4, which will give you 1. Hence, it will be equal to 1 plus 3 minus 1, which is then equal to 4 minus 1, which is equal to 3. In this example, the first number to look at is 2 raised to the second power, which is equal to 2 times 2, which is 4. So now the equation is equal to 15 divided by 3 plus 8 times 4 minus 3. After that, you will do the next multiplication, which is 8 times 4, which is equal to 32. Now the equation is equal to 15 divided by 3 plus 32 minus 3. Minus 3. The next operation is division, which is 15 divided by 3, which is equal to 5. Now the equation is equal to 5 plus 32 minus 3, which is now equal to 37 minus 3, which is equal to 34. In our next example, we do the bracket first, which is 7 plus 2, which equals 9. Now the equation is equal to 3 plus 4 minus 9, which is equal to 7 minus 9, which is equal to negative 2. In our next example, we will do the bracket first, which is 3 times 2, which equals 6. Therefore, the equation is now 6 raised to the second power, and that will give us 36. In this next example, we will do the bracket first according to Bondas. 10 plus 3, which is 13. Now the equation is equal to 13 times 2 raised to the second power. We then do the exponent, which is 2 raised to the second power, which is equal to 4. Now the equation is equal to 13 times 4, which is equal to 52. So in our next equation, we will do the bracket 4 plus 10, which is equal to 14. And that will give us 13 minus 2 times 5 divided by 2 plus 14. Our next operation is multiplication, which is negative 2 times 5, which is equal to 10. Negative 10. Now the equation is equal to 13 minus 10 divided by 2 plus 14. Our next operation will be division, which is negative 10 divided by 2, which is equal to negative 5. Now the equation is equal to 13 minus 5 plus 14, which is then equal to 13 plus 4 plus 9, which is equal to 22. Oh no, not again. Anyways guys, thanks for watching.